I want to do an example about how to calculate net torque. And so I've got my helper here. This is Olive. She's going to help me. You going to help me? Okay, good. So we've got this situation shown in the picture, right, where we've got this bar. So we'll draw ourselves a picture real quick. And you know, as with any physics problem, we should probably draw a picture to start with, right? So getting ourselves a picture drawn here. And then we've got this force right here that's applied right there, and it says it's 8 newtons at an angle of 40 degrees. And then over here, we've got this force right here. That's 10 newtons at an angle of 30 degrees. And so here's our pivot, right? And notice they told us that the pivot was at the dot. And so you see here we have one torque that's trying to rotate this thing counterclockwise, and one torque that's trying to rotate it clockwise. Now, recall that when we're talking about torques, we don't care about x and y. Since torques are rotational in nature, we don't care about x and y. We care about what direction they're rotating. So we care about positive, negative, being clockwise, counterclockwise. That's what we care about, right? And our convention, just by convention, we call counterclockwise positive. And again, that's just a convention, right? And so what is the net torque? Well, the net torque is the sum of all of the torques. So let's call this torque 1, and let's call this torque 2. And so just to be as general as we can, since this is sort of the first net torque problem we've done, we could say that we've got torque 1. We should decide whether it's positive or negative. And then we should decide whether torque number 2 is positive or negative. And we'll add those up, and that will give us the net torque. Okay, and so now I think we can decide, and we can plug in some our equation for torque, right? Remember that our definition of torque is that it is RF sine of phi, right? That's our definition of torque. Okay, so torque net, we just add up the torques, but since torque is a vector, direction matters for torque. We need to include a plus or minus. Well, which one is it? Okay, well, let's decide that now. This torque right here is trying to rotate this bar in a clockwise fashion. If you imagine this was the only torque on it, then it would rotate this bar in a clockwise fashion. And that is negative. So we have negative R1 F1 sine phi, right? And you know what? We'll call that phi 1 for now. Again, we're being very general here since this is the first torque equation we've done, this first torque problem we've done. Then we've got this torque right here. It's trying to rotate it in a counterclockwise or a positive sense. And so that should be plus, and again, we're being very general, R2 F2 sine phi 2. That equals torque net. And now we can plug in our numbers. So now we're going to have negative R1. Well, that is 0.25 times my F1. That's 8 newtons. And then we have sine of phi. That's sine of 40 degrees. R2, right, plus R2. That's our 0.75 times the sine of 30 degrees. And so this, then, when we run our calculator, we get positive 2.5 Newton meters. Okay, so that positive value tells us it is counterclockwise, right? Okay, so there's our answer. Mistakes, concerns that I often see with students. I often see students add the forces, especially if I gave you the same angle, right? Then I would see students add forces. And we're not adding forces, right? Each force creates a torque. We're adding torques, right? So we have to be careful. We can't just add the torques and use an average angle or one of the angles. I see students try and do that a lot. We can't do that. The other thing that I think is a little bit tricky here is that, remember what these all mean. R is the distance from the pivot to where the force is applied, right? And so what is R1 here? R1 is right here, right? So there's R1. and there's F1 right there, right? So r is the distance from the pivot to where the force is applied. It's not just the radius of whatever round thing is in the problem. F is the magnitude of the force. Phi is the angle between r and F. Now, technically, we would want to take R1 here and move it to here so that they were tip to tip. And then there's R1, here's F1, and we can see that theta is clearly the angle in between it. But sometimes students get tripped up. Do we use this angle right here, or do we use this angle? Which one, right? This is 40 degrees, and I just told you we use that, so I mean that works, right? This is 40 degrees, that makes this 140 degrees. You know what, this is one of those nice things where technically the angle we're using is this 40 degrees. It doesn't matter, and you can check it out, right? Because it turns out that the sine of 40 degrees is equal to the sine of 140 degrees. It doesn't matter, right? And so you get the same answer there, whether you use 40 degrees or 140 degrees. Similarly, over here, if you use 30 degrees or 150 degrees, you get the correct answer either way. It doesn't matter, so you don't need to worry too much about that. Okay, hope that helps.